Okay, in this video I'm going to show you how to compute the area, total area between a given function and the x-axis using definite integrals. Now, in general, the formula for total area between a given function and the x-axis on a given interval AB is the definite integral from a to b, so a and b are the limits, of the absolute value of f of x dx. So we have to be aware of where a function is positive and negative on a given interval before we can start. So this first problem is going to be relatively simple because we can determine that since all the values of x here are non-negative from 0 to 4, therefore both values, x values cubed, are non-negative. And we're multiplying by a positive coefficient and then adding a positive number. This whole function, 5x cubed plus 6, is strictly positive on the interval from 0 to 4. So in this case, we don't actually need the absolute value. We can just evaluate the definite integral of f of x from 0 to 4. So if we go ahead and do that using our integration rules, what we get is 5 times the integral of x cubed, which is x to the 4th over 4, using a power rule, and then plus 6 times the integral of x to the 0, which is 1. And that's just going to give us x to the 1st, which is the same as x. So remember, the integral of a constant is that same constant times x. And this is evaluated at the limits of 0 and 4. What makes it nicer is that when we substitute x equals 0, we know we're not going to get anything. It's easy to see that we get 0. Now, that happens when we have a polynomial. If we have like an exponential function, for instance, then we actually will generally get a non-zero value, so you can't take that shortcut in that case. But in this case, we can. So we have, substituting x equals 4, we get 5 times 4 to the 4th over 4 plus 6 times 4. And then substituting the value at x equals 0, as I mentioned earlier, it's easy to see we're just going to get 0. So now we just have to work this out, and we're done. So 4 to the 4th over 4, that's the same as 4 cubed. So we have 5 times 4 cubed plus 24. Well, 4 cubed is 64. Times 5 is 320, because multiplying by 5 is the same as multiplying by 10, which is easy, and divided by 2. So 320 plus 24 is equal to 344 square units, whatever the units might be. So that's the total area between 5x cubed plus 6 and the x-axis on the interval 0 to 4. Now, the second one, the second problem here is going to take a little more work because it's not clear just by looking whether this function is positive or negative on the interval minus 5 to 1. So what we're going to do is find where this function is equal to 0, and then that will help us determine whether the function is positive or negative. So to do that, we see that this function can be factored. So x squared minus 2x minus 8 factors into, well, we need numbers that multiply out to minus 8, but there's sum to minus 2. So since their product is minus 8, they must be different signs, one positive, one negative. So the numbers that would work would be plus 2 and minus 4. So we have x plus 2 and x minus 4. So this function is equal to 0 at minus 2 and 4. Now, we can forget about it being equal to 0 and 4. That doesn't concern us because 4 is outside of this interval. But the other root, minus 2, is in the interval. So what that means is chances are the function is going to change sign at x equal to minus 2. But we need to confirm that. So on this interval, we're going from minus 5 to 1. And then it's equal to 0 right around here at minus 2. So what we can do is we can actually substitute our endpoints, 1 and minus 5, into this interval and see if we get a positive or negative result. For instance, if I substitute x equal to 1, I get 1 minus 2 minus 8. So that's minus 9. So over here, it's negative. Whereas if I substitute x equal to minus 5, well, minus 5 squared is plus 25. So 25 plus 35 minus 8 is 27. So the value here is positive. So it's positive over here and negative over here. So that means to get the area, I'd be integrating from minus 5 to 1 the absolute value of x squared minus 2x minus 8. And what I would do here, since it's positive on one part and negative on the other part, I'm going to break this up into two integrals. First, from minus 5 to minus 2 of the function without the absolute value, and I can do that because it's positive there. And plus the integral from minus 2 to 1 of the negative of this. So minus x squared minus 2x minus 8. Okay. Now, fortunately, once I work out the first one, the second one will be a lot easier because it's just we're just changing the signs of certain things. So I'll go ahead and work out this one first. So using a power rule, the integral of x squared is x cubed over 3, and then minus the integral of 2x is 2 times x squared over 2, so that's going to be minus x squared, and then the integral of minus 8, remember the integral of the constant is the same constant times x, so minus 8x with limits minus 5 and minus 2. Now, for this part, the indefinite integral of this function is just going to be the negative of the indefinite integral of this function. So I don't have to go for a power rule of this all over again. I'm going to have plus, and then I have the negative of this. So minus x cubed over 3 plus x squared plus 8x with limits minus 2 and 1. Okay. Now, you know what? Here's what I'm going to do. I'm going to pull a minus out of this whole thing. And a minus here. That way I have exactly the same expression here and here. And that's going to be helpful for when I plug in x values. Okay, because now what I'm going to do is I'm going to have the value at minus 2 with a plus sign, minus the value at minus 5, and then minus the value at 1, and then minus and minus, so plus the value at minus 2. In other words, the value at minus 2 gets added in twice, and I subtract the value at minus 5, and I subtract the value at 1. So if I substitute in minus 2, and so you'll see what I mean when I write this out. So I have minus 2 cubed is minus 8, so minus 8 thirds. And then I have minus 2 squared is positive 4, so minus 4. And then I have plus 16. So this is a value at x equal minus 2. And then I subtract the value at minus 5, so that gives me minus 125 over 3, minus 25, plus 40. Okay, and then over here, I'm going to subtract the value of this at plugging in minus 1. So I have 1/3 minus 1 minus 8. Okay. And then what's going to happen is, normally what I would do is I would subtract the value at minus 2. But there's already a minus out here, which means I'm going to add the value at minus 2. But I already have that over here. I'll label these other ones as well. So instead of writing it out again, I'm just going to put in a 2 there. So this is something that can happen in general with these area problems where you have to integrate one part where it's positive and another where it's negative, that two terms are going to combine. That always happens. Okay, so now I can write out all the numbers I have here. Unfortunately, I have some fractions. So I have I'm going to group all the fractions together because maybe they'll combine into a whole number. So I have minus 16 thirds plus 125 thirds minus 1 third. Okay. And then for the other numbers that I have that are all whole numbers, I'll have minus 8 plus 32, plus 25, minus 40, plus 1, plus 8. Okay, so my answer is here. I just need to work it out to a nice number. So first of all, the 8's are going to cancel out, so that helps. And then I have, so then I have, here I have minus 16 plus 125 minus 1. This is equal to 108 over 3. And that actually is a whole number. It turns out to be 36. So now if I just combine the rest of these, then I have everything I need. So 32 plus 1 is 33, plus 25 is 58, minus 40 is 18. So all of these add up to 18. So 36 plus 18 gives me 54 square units. So that is my final answer. So if you're not sure whether a function is positive or negative on a given interval, see where it's equal to 0 first, and that way you can determine where it's positive and where it's negative. And then you can break up your integral of the absolute value into 2 or more integrals over separate subintervals where you're integrating either a function itself if it's positive there, or you negate it if it's negative there. And when you see where you have to substitute in your limits, where you change from one piece to another, it always gives you an opportunity to combine like terms. So that's something to be aware of to save yourself a little time. So in general, if big F of x is the integral of little f of x, so then the area let's suppose that you're integrating from a to c of f of x because it's positive on this interval, and then again from c to a, c to b, minus f of x, little f is what goes in here. Okay, dx. Then what you get is, this integral is equal to big F of c minus big F of a. And then here we have minus f of b plus big F of a because of a minus in here. So this always simplifies to, that should be a c. 2f of c minus f of a minus f of b. So if it's positive in this part and negative on that part, then this is what happens. If you have a situation where it's negative on the first part and positive on the second part, same idea, it's just that all the signs would be reversed. So that's something to keep in mind as a possible shortcut. And there's no need to integrate both of these separately, just integrate one, and then the other is going to be the same thing with the opposite sign. Another way to save yourself some time.